to everyone, welcome back to my YouTube channel. So for today's video, we have another topic, and this topic is entitled partial derivatives. So to define the partial derivatives, it is a derivative where we hold some variables constant. Like in this example, so have you see the graph? So for example, a function for a surface that depends on two variables x and y. When we find the slope in the x direction while keeping y fixed, we have found a partial derivative. Or we can say that we can find the slope in the y direction while keeping x fixed. So let's first think about a function of a variable x, which is the f of x is equal to x squared. We can find its derivative using the power rule, which is the first derivative of x is 2x, right? Now, what about a function of two variables x and y? So we have f of x and y is equal to x squared plus y squared. I mean y cubed here. We can find its partial derivative with respect to x when we treat y as a constant. So we need to imagine y is a number like 7 or something. Okay, so we have the first derivative of x is equal to 2x plus 0 is equal to 2x. So for the explanation of that is the derivative of x squared with respect to x is 2x. Remember that, right? We treat y as a constant, so y cubed is also a constant, right? So imagine or think, if y is positive 7, then 7 cubed is equal to 343, since 7 times 7 times 7 is equal to 343. So it is also a constant, and the derivative of a constant is 0. Now, to find the partial derivative with respect to y, so we treat x as a constant. So we have the first derivative of y is equal to 0 plus 3y squared is equal to 3y squared. So for the explanation of that is, we know treat x a constant, so x squared is also a constant, and the derivative of a constant is 0, as what I have said earlier. Then the derivative of y cubed with respect to y is 3y squared. So that's why it is 3y squared here. That is all there is to it. Just remember to treat all other variables as if they are a constant. When there are many first derivatives of x and first derivatives of y, it can get confusing. So a mental trick is to change the constant variables into letters like c or k. So that's look like a constant. So we have example, f of x and y is equal to y cubed sine x plus x squared tan times y. So it has a first derivatives and first derivatives of y all over the place. So let us try the letter change trick with respect to x. We can change y to k. So we have here. So f of x times y is equal to k cubed sine times x plus x squared tan k. So we have the first derivative of x is equal to k cubed cos times x plus 2x tan times k. but remember to turn it back again. So we have to turn it back again. Likewise, with respect to y, we turn the x into a k. So f of x times y is equal to y cubed sine times k plus k squared tan times y. We have the first derivative of y is equal to 3y squared sine times k plus k squared second squared times y. So first derivative of y is equal to 3y squared sine times x plus x squared second squared times y. But only do this if you have trouble remembering, as it a little extra work. So this is all about the partial derivatives, and I hope you have learned even small things about this topic. Thank you for listening.
And if you are new to my channel, don't forget to like, share, and subscribe. And don't forget to hit the notification bell below for you to watch my next upcoming video. Thank you and God bless everyone. See you in my next video. Bye bye.